Hey, I'm Pascal from Orangepixel, and I had a great idea for a new Techtalk Tuesday series. At least I think it's a great idea. Let me know in the comments below what you think about it. My goal with this little series on the Tuesday is to mostly focus and aim towards other game developers. Or if you're not a game developer but are very interested in how does a game work internally, then this series is for you. The idea is pretty simple. I open up the project file for one of my commercially released games and we just go through it, and I'll talk you through some of the things I see there and some of the ideas and some of the stupid ideas and bad code, but all of this works. So for this first episode I wanted to grab a fun game that's been released on like a lot of platforms, Gunslugs. It's a pretty old game, pretty old code base. I think I created it in 2011. The code is messy, but the game has been released and sold on platforms like Android, iOS, PC, Ouya, Chrome OS, Firefox OS, PS Vita, 3DS, and it's now on the Switch. It's been released on a lot of platforms and it's still being sold everywhere. It's still a great little fun game. So after the intro we're gonna dive into the source code of it. Okay, so like I said, we're gonna open up Gunslugs. It's been, I know this code is very messy. There's a lot of decisions I made in this game, but most of my goals with this game was just get it up and running and release it. So some of this code is not pretty. There are much better ways to do it, but even then it's still a good example on how not to do it. So let's just dive into the code, and I'm not gonna screencast this, I'm gonna show you with this camera so I can point at stuff, and that's just how I like recording it. I think it works faster and better and makes it a lot easier for me to make extra videos and extra content, so go with it. Alright, so the Gunslugs code was originally written in my own engine, but in 2015 I think I ported it all over to libgdx. I'm still using my own framework, so I use very little of libgdx itself. For example, I used like the core application listener, just core handling of input and screen stuff, but all the other code is my own code. So over here on the left side we have a list, and pretty much everything underneath Gunslugs, all these are actual game code. Everything else is mostly my framework on what I build games. So let's just start with bullets. Pretty much the easiest of the classes. This handles all types of bullets. We have bullets, tripod, lasers, rockets, explosions, just a bunch of different entities. And we scroll down. Bullets can be owned by the player or player 2, because Gunslugs comes with a local co-op mode, and this could have been just one player bullet, but I made it a player 2 bullet as well, because maybe we would have been able to add like players shooting each other, and I wasn't sure on that when I designed it. So now there's a good distinction between player 1 bullets and player 2 bullets, monster bullets, or anybody, and that's pretty much environment like things. So they're not being shot by anything or not being spawned by anything, but they're part of the environment. So then we have a bunch of properties that all these bullets share. We initialize bullets over here, and for every bullet type we just have an initialization, different changes. This defines how it looks, how big it is, and all these type of settings. Then we scroll down. For every bullet there's something to initialize, and all the way down here we go in the update. This is what's being called like every update, so 60 frames per second, 60 times per second for every bullet on the screen. We call this bunch of code, and then again, it's not very clean code, but it works, and that's usually my main important goal for when I write code. I want it to work and have a finished game. So, and then we just check which type of bullet are we, and handle our artificial intelligence or our game logic or whatever you want to call it, which is a bunch of things, and mostly it's just moving our position and checking if we are hitting something. That's pretty much everything a bullet does. And if we hit something, it can do various things, but the core stuff is move our bodies or move our bullets, and then check if we are hitting stuff. And we do that for every bullet. And of course, the movement is different depending on the type of bullets. That's why we're splitting all that stuff up, because every bullet has its own movement. And of course, also its own rules when it hits stuff. For example, you could have bullets that split up and bounce in directions as soon as they hit a wall or something. So that's what you build in this part of the code. So that's a bullet list, which are entities on the screen, and the same thing can be said for special effects. I always have an effects class in almost all my games, and this is just, in most cases, non-interactive stuff. So we have little twirls that if the player jumps, you see these little smoky twirls on the ground and flying up. Big explosions. It's really exactly what it says it is. Special effects. Fire bulbs used in the jetpack. I think that's the little thingy underneath the jetpack. Shells flying out when you shoot a bullet. Just a bunch of special effects, and these have very little interaction with everything around it. They just exist, do their animation, their movement, and then they die off. And again, it has an initialization right here, and every type has an initialization. And then, back in these days of Gunslugs, I created cartoony like bubbles. So this is literally the word rat-tat-tat. This is the word click, and the blah. These are all just words that pop up when stuff happens. So we scroll down, and there's a lot of words, and this could have been done a lot more effective, because we could have put this in an array or something and not have to do all this code. But oh well, you live and you learn. Like I said, this is very old and outdated code. And of course, it starts with just one thing, and then you decide, oh, I want a few more. And before you know it, you have 36 different subtypes. And yeah, could have been done a lot better. So those are all the special effects and the initialization code. And then, of course, we also have updates. And again, this update is being called 60 frames per second for every special effects on the screen. And then we do all the animations and movements for it. And it works pretty much like bullets. There's not a lot of code. Most of these things are just animated. Some actually move. Some don't even move. They just fade out. And a very simple special effects class. But I like having this class to just do the weirdest thing in games. And it's just everything that's non-interactive. Bringing us to globals. And this is pretty much just where I keep all my global variables, including, and this is funny, these are variables included from the Heroes of Loot. I guess I copied this globals file from the Heroes of Loot version, because there's no elf, warrior, or wizard in Gunslugs. This is just, this is also not used. That's why it's gray. This isn't used. But yeah, sometimes you just have, you leave stuff in a game that doesn't really need or isn't used at all. I think this happened when I moved Gunslugs over to libgdx, because most of the stuff here is literally Heroes of Loot stuff. So well, here's some, this is in all my globe, and this is not weird that there's Heroes of Loot stuff in here, because this globals file is pretty much the same in all my games from this point on. It has a debug message, but it also has a random generator, filling random table full of random numbers. A couple of these functions will be in all my globals in all my games, and that's why I call them globals, because then I always know where to find them. They're part of the game, but they're also part of like every game I make. And moving on to the GUI, well, this is just pretty much handles everything in my settings menu of a game. So it handles keyboard input, but it also handles rendering progress bars, buttons, things like that. Literally, it's the interface part of all my games, so that I know where to find it. And I copy this from game to game, and then I change it a little bit. So if you look at my latest game, Residual, this GUI file will still be there, but it will be much more and better improved, and it has more, it contains more, it's better. But this is where it started, or about this is where it started. And all this does is render progress bars, render buttons and texts and things like that. It's not really exciting and not really part of the main game. as you see, a lot of this, all this grayed out stuff, it's not being used in Gunslugs, but it's part of this class because it's part of all my games. And Dewey Listener is just a part of Dewey. This is where things happen when you press a button. It will be selected or previous next, but blah blah. This isn't really interesting at all, but it's required, and it makes it a lot easier for me to build an interface or a menu screen because I don't have to reinvent all this code every time. And that brings us to the monster entities. Again, this is pretty much the same as both the bullets and the special effects, but this is where all the monsters or enemies or whatever you want to call it, they are all in this file. And this game is pretty small, so there's not a huge amount of creatures running around or different types. But in Residual, I already had to split up this monster in like about 3 or 4 different types because there's just so much more going on. But for Gunslugs, we could easily manage all of this. Even the big boss fights, the big bosses are here. They're like screen-filling bosses, but they're just the same as a tiny enemy because it all works in the same way. So again, we have all the properties of these monsters. We have the, we can copy monsters, which rarely used, but it's always good to have. And here we initialize it, again, like the same with special effects or bullets. This is pretty much setting the default values. And then for every type of monster, we give it properties and set up how it looks, how it acts, where it starts. And then we eventually end up in our, let me hang on here. And then we eventually end up in our update class. And again, this is also running at 60 times per second for every creature in the game. Unless it's not on the screen, then we are skipping all these things. And what this does is, all right, this is some interesting stuff. Gunslugs is a local cooperative game. So you have, sometimes you have 2 players and entities attack the nearest player. So what happens here is if we already had a target, then that's still our target. But if we didn't, we are going to be looking at the nearest player. And this is a very simple calculation. Which of the 2 players is closer to me, that player is going to be attacked by us. And that's how it's deciding who to attack. So if you're playing Gunslugs with 2-player mode, just make sure the other player is closer to the enemies and they'll never attack you, just your friend or buddy. So that's just a little fun tip to have more fun in Gunslugs. Just lean back a little bit and let the enemies attack the second player. Other than that, it's just, again, all the logic, and this is really... this requires a lot more than the bullets and special effects because, well, enemies have to attack the player, so we need to decide a bunch of things. Are we jumping on the player, or are we being jumped at, or just those type of things? Are we dropping in from a parachute or from a helicopter? Then we do this. If we're dropping, if we're on the ground and we're done, we're walking, then we move to another state. And this is just a bunch of states that the soldier can be in. And we have a bunch of states for every enemy type. This could all have been optimized a little bit more by moving all this code in special functions, because that way this code could be used by various other entities as well. I'm not sure that is needed in this game. For example, do gravity, as apparently I did put this in a function, which pretty much makes the player drop down, or every entity drop down until it hits a solid. And it just moves through all these little states. And these numbers, I could have given them names, because this is just... When I'm looking at it now, a good thing there's a comment there that says walk. Otherwise, I had no idea what was happening here. It's messy. That is probably because I've been programming the games myself. I don't have a team, so I don't really have to care what others think or if other people can follow what I'm doing. For me, it's just get it up and running and then move on to the next thing. And if it ever bugs out, we'll figure it out. So monsters in this game are not just enemies. We also have avatars, little characters that you can talk to in the stores and in the shops. They're pretty much the same as a monster, except they don't attack the player. They just interact with the player. And we have entities for all types of things, and even platforms that Elevator-like platforms are also entities in my games because they work pretty much the same as an enemy. As soon as the player steps on this platform, it either goes down or up, and that's all the interaction it does, but it still requires the same kind of logic as all other entities. So that's what we do with all these logical things. And again, a bunch of this stuff could have been done a lot better, but it works. Now let me see if there are some other interesting functions that I could talk about in the entity. Check hit player, which is pretty simple, self-explanatory. Get finger. I think this is for the touchscreen. Yeah, it doesn't. Oh, right. This is for one of the end bosses. He has like these big fingers, and this little function gets one of those fingers. It's weird. Why do I even put something like this in a function and a bunch of that other code? I didn't. But sometimes code just doesn't make sense, and that's okay. So nothing very spectacular in this entity other than just a bunch of game logic and monster logic, and that's how we build up a game. So all the enemies, everything that's moving and interacting on the screen is mostly happening in this class. Then I'm gonna skip the canvas for now, which is the main class. This is just the player class, and it's a single entity, so even this one could have been put in a monster file, but the player always gets its own file from me. So just a bunch of properties for the player: weapon, character ID, status, and often I start with just a couple of properties, and by the time a game is done, there's a huge list. And again, this can be optimized in various ways, but this works, and it doesn't really slow down the game having so many variables. So that's just the easiest way, I think, or at least I think it's the easiest way. It works for me, and that's the most important thing. So the player also has an initialization, and of course it also has an update method. It has a die method because usually if a player dies, there's more stuff happening on the screen and things like that. We spawn particles, we have to check certain things. And the player can die while he's in a tank, driving a tank entity. In that case, he's not losing his lives. He's just thrown out of the tank. So there's just a bunch of extra checks here and there. But it's pretty much the same type of code as you would give an entity, except this one is controlled by a player. So the movement, the direction, all that stuff comes from the input. Everything else works pretty much the same as any other entity in a game. So let us see if there's something else here that could be interesting or is different. No, not a lot of exciting things happening in this class at all. Movement and handling of scores and in your life and stuff like that, because it's the player entity, so it's important. And then we have a player profile, which is pretty much saving the settings to a file and has just all the settings that the player wants, using music or not, sound effects, stuff like that. It's just a big, or this is all the achievements, just a big list of settings and preferences, and those are saved and loaded at the start and the end of the game. So that's the player profile and all those things. Right here we have a render and a tile map. Render pretty much does what the name suggests. It renders stuff on the screen. So this links into libgdx, the library, but it's still my own code for the most part, so that even if I decide to ever move to another library or whatever, this code doesn't have to change. I just have to change this code, but the calls to this code will always be the same, which makes it a lot easier to port stuff to other code bases. And that brings us to tile map, which is the world. Everything you see around you, the solid stuff, the walls, the floors, that's all being placed in tile map. It has a bunch of extra things like, is this game in co-op mode? How many players are alive? Are we in a tutorial mode? And things like that. So there's a bunch more information being stored in the tile map than just the tile map. So this is a weird name. In later games I just call this the world, a class, and that makes more sense because the whole game world is stored in this file and not just a tile map. So a lot of little functions that just create the world. In this case there's no tile map being loaded from files. We actually put solids and cut solids out based on data and procedural generation like this, and we then process it, give it a texture so that it all looks correctly, and that's pretty much what this whole class does. Generate zone 1. This is, let me see, yeah, there are different type of levels. The first zone is pretty much, it has no gaps where you can fall, while another world might have gaps where you can fall through the bottom of the screen. And this is how I split it up. So we have zone 1, and then we of course also have a zone 2. And I think we had a zone 3 as well for the hell world, which is again completely different, and it mostly little platforms everywhere. So it has a different layout. And this code just generates that world. So no tile map being loaded, nothing is designed. It's just a code that creates the level around us. That brings us to the final and the main class. This is the My Canvas. I'm not sure why I called it My Canvas, but this is pretty much where the whole game gets initialized. Everything gets set up. It calls the right stuff. So we have all these various screens for the game, interfaces. We have a splash screen, the start screen, the menu settings. Pretty much every little phase in the game has its own state here. Then we have all these lists, and this is where all the bullets and the entities live. We create a list, and we pretty much create that list at the start of the game as soon as it loads. And then we have already have 128 bullets, 256 monster spots. So we don't have to recreate those. We just reuse those spots, ready to be initialized in any type and any way. And as soon as they die, they can be re-initialized as another type. Here we have all the stages like a splash screen. This is for the iArcade version. I just added this. So there's a little iArcade logo popping up. This is the Orangepixel splash screen right here. A settings menu, and pretty much for all these things we have different settings or different screens and different states. And then there's a bunch of interesting stuff. Let me see what's more interesting here. Adding bullets to the list, pretty simple code. Find an empty slot and then we add a new bullet there. Rendering all the bullets, updating all the bullets, and that goes for the monsters and the special effects as well. And we have handling of controls, which looks at either keyboard, gamepad, or touchscreen. And we have special effects adding, we have music loading, initializations of animations, and all those type of things. Is there anything that stands out here that's really weird? Well, different zones, which pretty much loads in the graphics for the different levels, and then calls the tile map to produce a level for it. So also pretty standard and straightforward. Play background is for playing the audio. Play shooting sounds, play other sounds. And not sure why I split these two up. These days I just have one play sound function. And then we have rendering all various type of things on the screen, from achievement pop-ups to the background to info boxes, menu options, and the actual game scene. Oh, this might be an interesting one. Here we render the parallax layers for the background as the first thing, depending on the type of level we are in. And then we start adding special effects, adding all those on the screen. Then we render all the entities, and they come in different these numbers here. They pass along which layer we want. So just in case, sometimes you want special effects to appear on top of all the entities. So then what you do is do another FX render, but give it a 1 or a 2 to make sure that all the special effects you want on layer 2 are rendered on top of that. It's just a number, and it's not a different layer because it all get rendered in the same way. But that number just indicates we want all the special effects that have a importance of number 2 to be rendered now, or importance of number 1, etc. And of course we render the tile map, which is important because that's all the solid stuff, all the ground you walk on and all the walls you bump into. and then at the end we render bullets, and oh well, we actually have more special effects rendering right here, pass 1, 2 and 3. This could have been done in this game, in this particular case, better by just having a sorting number and just sorting the special effects, because there's nothing being called in between these. So this could have been more optimized and faster, but this also works, so sure, why not? The worst case here is that you go through a list of special effects and like 128 special effects, and none of them need to be rendered or handled. That's the only downside, which is microseconds or milliseconds or whatever. It's not really damaging the speed of the game at all. So let me see if there's other interesting stuff. No, that's about it, I think. We have things like unlock achievements, and this pretty much calls and checks if there are new achievements made and done and had, and if so, it can actually, depending on this My Social class, it will unlock it on either Google Play achievements or iOS Game Center or Steam achievements. So I think that's about it. That's Gunslugs. So that's a lot of talk, and that's pretty much the code for Gunslugs. Now, Gunslugs was not a huge game. It was, as you can see, there's not a huge amount of code. There are monsters, special effects, and bullets, and that's what makes the game tick. Still, the game is fun, interesting. It has been released on a bunch of stuff, and it's still being updated and maintained by me. So every now and then I just refresh a bunch of things. Like I recently implemented new gamepad support for the PC version, so it now can be played with a lot more controllers. And by keeping it updated like this, I keep this game alive, and that means it keeps making money. So over the decade, it's been well worth it to just release it on more and new platforms every time. And of course, there's been a Gunslugs 2 and there's a Gunslugs 3. And if you like this series and this look into the games, then I'm sure we'll get to those games as well. If you like it, let me know in the comments below, but also let me know which of my games would you like me to dive into, except Residual, because it's not done yet, so there's no point in diving into that. But all the other games, let me know which one you'd like to hear about, or see some code behind, or have specific questions on how certain things were done in any of my games. But that's it for this first episode of this new Tech Talk series. Let me know what you think about it, and on Thursday there will be a normal standard video devlog thingy, so make sure to check every Thursday. Still working on Residual. So Thursday we'll be talking about Residual. So see you on Thursday. All right, bye.